Okay, last day as we're exploring all the transformations for our sine and cosine, and then what we'll end up doing is we'll look at cosecant and secant, and we'll look at cotangent and tangent. But all the strategies and all the procedures that we're learning for sine and cosine also play into cosecant and secant and cotangent and tangent. There's slightly different ways to graph those things, but in general a lot of the principles are the same, where we actually are still analyzing like a period change, and we're still looking for a vertical shift or a phase shift or an amplitude difference and all that other good stuff. So today is the last day that we talk about just our basic transformations, which is our vertical shifts. So we are going to look at the graphs of 3 plus sine x and negative 4 plus sine x first. So kind of the same way we've been starting out. I'm going to start by graphing sine x. So we've been looking at this graph a lot. We know we have 5 critical values for our normal period. 0, pi over 2 gives that maximum here of 1. Pi gives a 0. 3 pi over 2 gives that minimum of negative 1. And then back to 2 pi will complete that cycle. So we are going to look at 3 plus sine x. Let's see what that looks like. Oop, can't actually see it. So I'm going to zoom out. So again, this is our normal sine x. And now what's graphing next is 3 plus sine x. And it ends up being like exactly the same as our function below. The only thing that happened is that we shifted the graph up. So normally, I'm going to zoom in kind of in this general area here. Normally our 0 happens at 0, but in this case, that's our sine x, our 0 that is actually happening at 3. So that kind of makes sense, since we're doing 3 plus sine x, that our 0 is actually shifting up 3 units. Kind of like when we talked about range and domain from before. When I look at our like normal domain of like y equals square root of x, and then or my normal range, and then I add 5 to it, that's like our new starting value. So this is kind of our new starting value. We're shifting it up 3 units. That what I'm going to call, in most cases, I'm going to call that our baseline. So we're going to graph our new horizontal, our new baseline, and then from there everything is pretty much the same. So same idea. The next one we're going to graph is negative 4, which you can probably guess what that's going to do now. So that's, again, normal sine that's graphing, kind of hugging the x-axis. And then this is our negative 4 plus sine x graph that's just shifted down. And again, like our 0 that's actually happening here is at negative 4, but we still have those maximums and minimums happening at those same critical values. So it doesn't affect where those critical values happen. All it does is shift it up. So this shifts it up 3 units, and this shifted it down. That's 3. So now our standard form, this is not really for now anymore. This is actually like the full standard form. This is all of our transformations. We know that this affects our amplitude. We know that this B affects our period change. We know that this D affects our phase shift. So a minus would move it to the right, a plus would move it to the left. And now we're adding on this C value. This C value could be in front or it could be behind. It doesn't matter. A lot of times in the book you'll see it in front. But if I have plus 5 here or 5 plus, you'll have the same vertical shift. So if C is bigger than 0, if this is some positive number, then we're going to shift the graph up C units. But if that C is negative, we shift the graph down C units. So luckily, if you're still a little bit fuzzy on all of the period changes and the phase shifts, we are going to still practice that today. The only difference that we're doing is adding on a vertical shift, and that ends up happening. So like this is pretty much word for word of everything except the amplitude, and in step 4 we're inserting a vertical shift. Okay. The other thing that we're going to add on today is stating the range. Now the range so far has been from our amplitude, bottom of our amplitude to the top of our amplitude, but this one will be like slightly different as we look at our graphs. Okay, So let's start. We have, first thing we have to do is put it into standard form, which means that we have to factor out that b if we need to. So for this one, do we have a b outside of these parentheses here? Definitely not. Like it is by here, this x, but we need to factor it out. So that's the first step. So I'm going to factor out a 3. And when I factor out a 3 from that parentheses, obviously this one turns into x. This one I'll do 3 pi over 2 divided by 3. So if I reduce that, I get 3 pi over 2 times 1/3. So these 3's will cancel out, or it'll have 3 pi over 6, which will end up being pi over 2. So that's going to be our phase shift, pi over 2. So our amplitude, as I'm making my list of everything, my amplitude is 2. My period is going to be 2 pi over my b value, which is 3, so 2 pi over 3. My starting x and ending x. And then the last thing we need now is our vertical shift. So our starting x is plus. We have a plus pi over 2, which means we're going to shift to the left. So our starting x is negative pi over 2. And our ending x value is negative pi over 2 plus our period, which is 2 pi over 3. Now, I didn't actually show this, but you can find that value in your calculator too. Like last video, I went through a lot of the calculations by hand, but you can just type that into your calculator. Just ignore the pi's, just like we've been doing. So negative 1/2 plus 2 over 3, and then you can turn that into a fraction. And you'll get 1/6, which will be pi over 6. And then our vertical shift is right here. That's the new part. So we're going to shift the graph up 4 units. Okay, so we're starting over here at negative pi over 2. And we're going to end at some positive pi over 6. So when we find the averages between those, I'll do negative 1/2 plus 1/6 divided by 2, and then average that, or find the fraction for that, and you get negative 1/6. So negative pi over 6 ends up being here. If we average these two, I'll have negative 1/2 plus negative 1/6 divided by 2. Find the fraction, you should get negative 1/3, so that'll be negative pi over 3. And if I average these two, negative 1/6 plus positive 1/6 is 0. 0 divided by 2 is still just 0. So those are our 5 critical values of our function this time of sine x. Next thing we're going to do is we are going to shift or look at, so we've done this. We've done the standard form, we found the period, we found the phase shift with our starting x value, ending x value, we found the average. The fourth thing that we need to do is pay attention to this vertical shift, which shifts the graph up 4 units. So this is now our new baseline. So I'm going to draw a horizontal line so that we can actually see this a little bit better. That's our new x-axis. So when we graph our sine value, we're going to graph on this new baseline, this new x-axis as we've shifted it up. From there is our amplitude, or there our amplitude comes into play. So from this baseline, our amplitude is 2, so we're going to go up 2 and down 2 from there. And that actually helps us find the range. So after we graph this, we'll come back to the range, but that's the idea, is that we're actually going from this new phase shift of going up 4 units, so we can come up with our range of the whole values that our sine function actually completes. So again, normally sine has zeros at the first, third, and fifth critical value. That's still true, but our zeros are actually on this new x-axis. So we have zeros at negative pi over 2, we have a 0 at negative pi over 6, and a 0 at pi over 6. And then sine is going up 2 units, again, from this new baseline. So we're plotting our new point at 4 plus 2, which is 6. And then we're plotting our next point at 4 minus 2, which is 2. And then that would be our sine function. Okay, so for our range, this is kind of the idea, is how high do we actually go? Well, we already said that it's actually from then our new phase shift, our vertical shift, and we're going up the amplitude and down the amplitude. So for our phase shift, sorry, I keep saying phase shift, I mean vertical shift. If our vertical shift is up 4 units, then we are going to add 2 to that to get our new top value, because normally if we don't have an amplitude here, it's 1 to 1, negative 1 to 1. If we have a 2 here, it's negative 2 to 2, but this is going negative 2 to 2, but then plus 4. So we're going from 4 to up there, which gives our top value of 6, and then from our 4 that we have, we're going down to 4. So again, we can get this value because this is really our vertical shift plus 2, and this value is our vertical shift minus 2. So really to find the range of our sine and cosine, we just have to take our vertical shift and we have to, so I'll write this out here, our range in general is our vertical shift plus or minus our amplitude. That really gives our range starting and our ending values. Okay, so let's do another one, kind of the whole process. We only have 3 to do today. So again, first thing that we have to do is make sure that's in standard form, which means we have to take out our b if we need to. So this one, definitely need to. So we have negative 1 minus 3 cosine. We're going to take out a 4, so we're going to left with x plus something. So let's figure that out. I would take out a 4, which means I'm dividing this thing by 4. So in other words, I'm going to multiply by 1/4, which is 3 pi over 8. All right, cool. So let's do our amplitude, our period, our starting x, our ending x, and our vertical shift. Those are now the list of the things that we need. So our amplitude is in front of the cosine, so that's 3, but it's negative, so don't forget that. So 3, and we're going to have some sort of reflection. Our period is 2 pi over our b value, which is 4, so 2 pi over 4, which we can reduce down to pi over 2. Our starting x value, this is plus, so we're going to start at negative 3 pi over 8. And to find our ending x value, we take our period and we add our starting x value. So negative 3 pi over 8 plus pi over 2. And again, you can do that in your calculator or by hand. So this, if I wanted to get a common denominator, it'd be over 8. So I'd multiply this by 4 over 4. So this would be 4 pi over 8 to get pi over 2. So I'd get a total of pi over 8 here. But again, you can do that in your calculator. Just do negative 3/8, just ignore the pi, plus 1/2, and you can change that into a fraction, and you should get pi 1 over 8, which is pi over 8 as well. And our vertical shift out here in front, we're shifting this thing down 1 unit. Okay, so we're starting over here at negative 3 pi over 8, and we're ending at pi over 8. So here's negative 3 pi over 8. And then plot like pi over 8 over here. So we'll find the average between those. This is one that's pretty easily done in your head, but negative 3 pi over 8 plus pi over 8 is going to be negative 2 pi over 8, which is negative pi over 4. If we want to divide that by 2, we'll get negative pi over 8. But again, you can average it in your calculator, and that might be easier, and that's fine. If we want to do it this way, we'll have negative 3 pi over 8 plus negative pi over 8, which is negative 4 pi over 8, which is negative pi over 2. We divide that by 2, and we'll get negative pi over 4. And if we average this, negative pi over 8 plus pi over 8, that's 0. 0 divided by 2 will give a value of 0. And then all in all, we are going to shift this thing down 1 unit. So now our new x-axis, I'll do it in a different color so we can see that a little bit better. Kind of drew it all on my... Our new x-axis is down here at negative 1, shifting it down. So when I plot my cosine value, I want to make sure that I'm going from here. Okay? Which means that my altitude is like 3 up from there and 3 down from here. So I'm just kind of trying to make that to scale. Okay, so let's see. Normally, cosine starts, it has like that dip like a cup. So we have our zeros on the second and the fourth critical value. So that's where I'm going to plot my points at the negative pi over 4x value and the 0x value. Normally it starts up and it goes down and back up, but we have a reflection this time, so we are going to start down 3, which is down here at negative 4. Go back up to 0. At negative pi over 8, we're going up 3 units. Back down to 0, and then at pi over 8, we're going down an additional 3 units. I think I kind of overshot this one down here. That's okay. Oh, I can't see. So something like that. And we're going to figure out our range. So you can get your range from your graph, you can get your range from your amplitude and your vertical shift. I don't care which way you do. If you want to get it from your graph, we are going down to negative 4, and we are going up to positive 2. I almost miscounted there because I counted this as 1, and I was like, we can't go up to 3. But yeah, negative 4 to 2, and you should, like, one way you can check is if you average these, you should actually get your vertical shift. Like if I do negative 4 plus 2 and then divide by 2, I'll get my vertical shift of negative 1. So that's one way to double check to see if you're getting it right. But you also just like go from your vertical shift. Like I know that from my vertical shift I'm going down 1, and then I'm going to subtract the 3 because that's my amplitude of 3, and then this will be negative 3, 1 plus 3 to get to those values. Either way, I don't care which way you do it. You just have to make sure that you end up with your actual range. And last one for today. Again, the first thing that we want to do is see if we have to factor out something. We definitely do in this one. So we have to factor out, in this case, a 2/3. That's a little hard. So our first one is just going to be x. If I want to factor out, this will be minus. If I want to factor out 2/3 from 3 pi, I'm going to divide 3 pi by 2/3. Which means I'm going to multiply by the reciprocal. So that's 3 pi over 1, and then I multiply by the reciprocal of 2 over 3, which is 3 over 2. So I'll get 9 pi over 2. And then I have a minus 4. This again is my vertical shift, and we usually see it in front, but this being in the back here is no problem. Like it's not really an issue. We just have to make sure that we're still seeing it. So I'm going to make my list of amplitude, period, starting x, ending x, and our vertical shift. So let's start with our amplitude. That's easiest to spot. We got an amplitude of 2. Great. Our period is our b value, 2/3. So we're going to take 2 pi and divide it by 2/3, which is just what we kind of did over here. So we'll have 2 pi over 1, and we'll multiply by the reciprocal, so 3 over 2. We will get 6 pi over 2, which reduces down to just 3 pi. Our starting x value is all the way to the right, so like we'll have negative pi over 2, or 9 pi over 2, this minus, we'll move it to the right, 9 pi over 2 units. And then our ending x value is our starting x value plus our period. So negative 9 pi over 2 plus 3 pi. This again is 6 pi over 2, so negative 9 pi plus 6 pi is going to be 15 pi over 2. We're really stretching out in the x-axis here. In our vertical shift, we have this minus 4. We can't forget about that, so it's going to go down 4 units. So I'm going to start, so like this, I don't really care too much if you go to scale, but because 9 pi over 2 is kind of big and we're stretching out 3 pi, I'm going to start kind of over here a little bit just so that I can show that it's kind of farther away from my 0, because this would be like 4.5 pi, and I'm only going 3 pi, so really it'd be like over here, but I kind of want to give myself some room. So again, like, just make sure that you're somewhere over here. I don't really care too much if you're to scale. This obviously isn't. So this is my starting x value, and then my ending x value is way over here at 15 pi over 2. Just giving myself some room. So we can find the average between those two, 9 pi over 2 plus 15 pi over 2. Well, 9 plus 15 is 24. We would, 24 over 2 is 12 pi, and then we divide that by 2 and we get 6 pi. But again, you could do that in your calculator, like 9 over 2. You just have to get rid of the pi's. So 9 divided by 2 plus 15 divided by 2, and then divide that by 2, and that gives you our value of 6 pi. We average 9 over 2 and 6 pi, but again, if you want to do it in your head or if you want to do it by hand, you can add together like 9 pi over 2 and then 12 pi over 2 and then divide it by 2 and come up with the fraction. Either way, you should end up with 21 pi over 4. Kind of missed my 1 here. And we'll do the same thing here over here, 6 plus 15 over 2, and then divide it by 2 and turn that into a fraction, and we should get 27 pi over 4 for our last critical value. These all should be like equally spaced, so like you could find the difference. Like that's another way to do it, is to take our entire difference that we have here, divide it by 4, and then add it on each time. Just makes more sense, or it's a little bit easier to actually do the average between the two, and that's getting you your 5 critical values. Okay, we're going to shift this baby down 4 units. I'm going to run out of space here. So that's our new x-axis. It's like that. We are graphing cosine. Cosine has zeros at our second and our fourth critical value, so that ends up at 21 pi over 4 and 27 pi over 4. You don't have to draw the zeros first, it just helps me. And we have a normal cosine, here we go, without a reflection, so that means we're starting up, going down, and then back up. So we are going to start from our -4 and go up 2/3, which happens about here. And 6 pi, we're going to go down 2/3, which is about here. And then up 2/3, which is about here. So there's our function of cosine. Let's come up with our range. We'll actually have to reduce this, but so I'm actually going to write it out like I did here, and that will kind of help us. I know that my vertical shift is down 4, so I know that that's where I'm going to start in both of these cases with -4. And oh my gosh, you guys, I graphed this wrong. You're probably like, what is this lady doing? It's been a long day. I misread. I thought the amplitude was, I looked at my B value for 2/3. My amplitude's 2, so I'm going up 2 from this horizontal line and down 2 from this horizontal line. Not that one, this one. And up 2 over here. Ugh, so you can ignore that line. I'm sorry. Correct that in your notes. Not this one. Not like this dummy that I was when I looked at the wrong thing. So there we go. That's a little bit better. So we're still going to start at our -4, and we're going to add on our amplitude of 2. Sorry, this one we're subtracting our amplitude, and we're going to add it on this way just because it's a smaller number. So we should get -6 and -2, and we should graph this or find this in my correct graph, which happens 1, 2, 3, 4, 5, 6. There we go. There's the actual value, not 2/3. And then at -2. Sorry about that. There's our actual range. And we're actually using the right amplitude this time, not the B value that I thought we were using for a second. Okay, hopefully that didn't screw you up too much. Definitely easy to make mistakes, huh? Like, especially if you get these wrong or vertical shift, it does mess up your averages too. So make sure that you're double checking that, like I didn't. Okay, Last little bit for today is just kind of having a general overview and summary of what happened or what's happening when we have our given parent function. There's something like this, I'll just warn you now, there's something like this on your test, like for your chapter 4, so make sure that you're understanding where all these values are coming from and how they affect your graph. So this question is, what would happen to the graph of the parent function if the value of n increased? Well, n right now is that outside number. It's that really acting as a vertical shift. So if this thing increased, if n got bigger, that means that it would move the graph up, n units. Or n more units. It would move the graph more up. So like right now, if it was 1 plus some stuff, and now it's 3 plus some stuff, it moves it up that many more units. Okay, same kind of idea. So what would happen to the graph if the function of w increased? Well, right now we're doing plus w, so if I had inside my parentheses x plus 1, and then now I have inside my parentheses x plus, or I guess I'll say pi. Now I have x plus 2 pi. Well, this shifts the graph left pi units. This would shift the graph left 2 pi units. So if the IRW increased, we are shifting the graph further left. I guess we would say further up too. Shifting the graph further up that many units, shifting the graph further left that many units. What would happen to the graph if y increased? So if y got bigger, that's our b value usually, and that's what we divide our period by. So if we had something like 2 times x plus pi, and now we have something like 3 plus x plus pi, really what that does is it makes our period get smaller, because this means that we're completing that many more cycles within that time period. Like this is twice as fast and this is 3 times as fast. So you could say something about the frequency increasing, or you could say that our period, it shortens the period. What would happen to the parent function if the value of p increased? So the p is on the outside here, so that acts as our amplitude. So if p got bigger, it's something like 3 cosine of x plus pi, and now we're looking at 4 cosine x plus pi. Our normal amplitude is 3, and now we're looking at an amplitude of 4. So what that does is it makes our graph get taller and shorter, so this increases the amplitude, and I'm going to say it also increases the range, because the amplitude does affect what our range of our sine and cosine graphs can actually encompass. What would happen if p became negative? So if I looked at the difference between this graph here versus our normal one, what that does, that negative value that I have actually flips it over the x-axis, so this is a reflection. Reflect over the x-axis. Normally, like sine goes up and down like that, and now if we have a reflection, it goes down and then up. Same thing for cosine. Normally it goes, starts up, it goes down, and then goes back up. Cosine reflection would start down, go up, and then go back down. So it reflects it over the x-axis. This idea, again, of like being able to look at something with all these different variables and deciding what would happen if it increased or decreased or became negative or got smaller or reduced by 2 or whatever situation I come up with, you should be able to explain just like this of what would happen to that graph.